Good time of the day, dear colleagues. I'm really glad to greet you here at Moscow Junior and Physics Institute, Russian Federation National Research Nuclear University. We are considering the examples from our admission tests. And today we will consider a couple of exercises related to electrostatics. Oh, I'm sorry, related to circuit physics, to the physics of electric circuits. So they are more a little bit complicated than probably all the tasks that we may come across in other sections, but still let's try to do that right now. Well, let's first consider a simple one. Look at the scheme, look at the picture. Imagine that you have an electric circuit looking like that, consisting of 3 resistors. 2 are connected in parallel, where the resistance is 2 and 3 ohms, and 1, where the resistance 1 ohm, is connected to this couple in series. So the question is, what will be the total electrical resistance of all the circuit, of all 3, measured between points marked at the scheme to the left and to the right of it? So first, let's consider this couple of resistors connected in parallel. They have resistances 2 and 3 ohms. So the rule to calculate the resistance of a group of resistors connected in parallel dictates we should sum up the values inverse to resistances. If you take the value inverse to the first resistance plus value equal to the inverse second resistance, plus if there are more resistors connected in parallel, more inverse values, in the result you will obtain the value inverse to the total resistance of this group. So in our case we have 1/2 plus 1/3. It would give us 5 divided by 6R, or finally, when we try to extract the value of the resistance of this couple of connected in parallel resistors, we will obtain 1.2 ohms. Now the question is, what will be the resistance between the points marked to the left and to the right of this scheme? We should additionally add the resistor R. This one is connected to the first couple in series, and in this case, resistances simply shall be summed up. So the total resistance will be equal to R plus 1.2 R, 2.2 ohms. Let us consider one more example, a little bit more complicated, at least formulated in a little bit more complicated form. Imagine that you have a battery which produces voltage, some voltage. Now you want to measure which current this battery will generate, and you attach an ammeter. 1 ammeter will register the current 1 ampere. Now you take the second ammeter, absolutely the same by properties, by all the characteristics as the first one, and connect it in parallel to the first one. Each of the devices will show you the current 0.6 amperes. Total current will be 1.2. Now you connect 2 more ammeters. You have now 4 connected in parallel to the same battery. What you will have in this case? The question is, which current will register each of those ammeters? So in order to find the answer, you should know the Ohm law for the closed circuit. Closed circuit means the element producing voltage, the battery, and we'll just call something which makes this circuit closed, some external part of the circuit. So for any closed circuit, the current in the battery will be equal to the voltage produced by the battery, you see, of the screen divided by the total resistance of the circuit. Total resistance of the circuit consists of the internal resistance of the battery, of the element producing voltage, and external resistance of the circuit outside the battery. So, if you have the external circuit consisting of several ammeters, n ammeters, and maybe 1, 2, 4 in this exercise, all in parallel and all equivalent by characteristics, then it means that the total current flowing through the battery would divide into all the ammeters equally. So the current registered by each ammeter multiplied by the number of ammeters will give you the current in the battery. I think it's evident. Now we should only calculate the resistance of our external circuit. We already know from the previous example, if the external circuit are several resistors, ammeter can be considered as simply as a resistor from the electrical point of view. So if they are connected all in parallel, then we should sum up values inverse to resistances. It means that the resistance of 1 ammeter, probably we shall name it R1. Resistance of 2 ammeters will be twice as low. Resistance of 4 ammeters will be equal to 1/4 of R1. Resistances of many ammeters connected in parallel are definitely less than the resistance of each individual ammeter. So now we may only substitute this value into the closed circuit Ohm law and try to get the result, the answer for this exercise from mathematics. What will we have? Well, the current from 1 ammeter will be equal to the voltage produced by the battery divided by the R internal resistance plus R1 and the resistance of 1 ammeter. The current in case when we are using 2 ammeters. Through each ammeter it will be equal to voltage divided by doubled internal battery resistance plus R1. Now the current through the system of 4 connected and parallel ammeters will be equal and expressed by the same kind of expression, only instead of 2, I should put here 4. Now I may take the ratio of currents, for example, I2 and I1. It will be equal to the ratio of resistances. And out of this equation, I know the ratio of the current is 0.6. Now I can then solve the equation and find the resistances and find that the internal resistance of the battery should be equal to double resistance of each ammeter in order to produce this exactly correlation. After I know this ratio, I may try to calculate the ratio of currents when there are 4 ammeters used to the current where there was only 1. Result you see here, it will be equal to 1/3. So the answer is the current in case of 4 ammeters registered by each ammeter is equal to 0.33 amperes, 1/3 of an amp. Thank you very much. We will continue in the next video with new part of physics.